Okay guys, so this is the first in two videos I'm going to do where I go through some pretty darn difficult moles questions. They're all going to use the standard 6 methods, so if I don't teach you, you won't know what these are. If I do, it's from this double-sided sheet, which is basically, did my elephant suck my auntie? Did stands for decimeters and diagram. You've got to draw a diagram and convert all of your centimeters cubed into decimeters cubed straight away. The reason we do that is because you'll forget later. So that's the did. Did my. The my stands for your first moles equation, which will always start moles equals. Did my elephant. The elephant stands for your balanced equation. The moles you found out before will not be the thing you care about. So you'll need to adapt that to the thing you do care about by using your molar ratios. Did my elephant suck? The suck stands for sample. Now you don't always have to suck, it depends on the question. If there is a sample, now's when you look at it. Did my elephant suck my? The last moles equation always starts with what you're trying to find out. So look at what the question's asking. Did my elephant suck my auntie? Your auntie just stands for answer. Remember two things, sig figs and units. Minimum 3 sig figs unless the question says otherwise, and don't forget units. So did my elephant suck my auntie? There's also a lot of other tricks to remember which we'll be kind of feeding in as we need to during this question. So what I would do is pause the video, try this question now. You'll get so much more from this if you've actually had a go at the question. So pause it now. And now we're back. So I won't go through the question as you've just tried it. Let's just go through the answer. So first things first, let's draw our diagram. Well, having read through that, this is what my diagram should look like. This is really important because it's going to allow us to follow what's going on in the question so much easier than like this huge, massive, chunky paragraph. And a question could be bigger than this in the exam. A diagram lets us quickly see what we know about what. So I've got my aluminium carbonate. I know the impure mass and it's in a certain volume. We've added a volume and concentration of nitric acid. So I've not just written down 0.012, I've said the units so I can see, right, that is a volume. Oops, 7 watts, 7 grams, okay, that's a mass. So you've got to be detailed in these diagrams, and I've said what it's about. We then took a 25 centimeter cube sample, or 0.025 decimeters cubed, and titrated it against some sulfuric acid, and again we've got a little bit of details about that too. Most of the time, 9/10 of the time, your diagram will look roughly like this. It's very rare that it doesn't. So this is the general form. Okay, so let's go through this first question. Questions A, there's like an extra bit added on. It's an extra little trick, and then we can get into did my elephant suck my auntie? So find the moles of sulfuric acid used in the titration. Now, the question tells us the concentration in grams per decimeter cubed. So to convert that into moles per decimeter cubed, we use a little trick, definitely worth remembering off the top of your head. Moles per decimeter cubed is grams per decimeter cubed divided by mR. So you can feed in all those numbers and you will get a concentration of 0.2 moles per decimeter cubed. Also, it's worth doing a balanced equation. We're not going to be able to do our equation step unless we've got a balanced equation, which I won't go through how to do today. Basically, it comes out as this, a 3:1 ratio. So, we're going to get back to question A in a second. Let's move on to question B. Find the percentage purity of the aluminium carbonate. Well, the equation for percentage purity is pure mass divided by impure mass times by 100. You're always told the impure mass. Look, 7 grams. If you're not told the impure mass and asked to find the percentage purity, you're wrong, you have. Check, you've just missed it. You're always told it. So when the question says find percentage purity, what it really means is find the mass. So let's remember that later on, okay? Percentage purity basically means find the mass. We'll come back to that later. So, this question's a little bit difficult because our aluminium carbonate is first reacting with the nitric acid, and then the remaining aluminium carbonate is reacting with the sulfuric acid. If I want to find the total amount of aluminium carbonate that I have, I need to find the number of moles of aluminium carbonate that has reacted with nitric acid, and I need to add that to the number of moles of aluminium carbonate that has reacted with sulfuric acid. It's like if I went to Asda's and spent £10 and then went to Tesco and spent £15, how much money have I spent? Well, you just do 10 out of 15, don't you? So 25. Aluminium carbonate is reacted with two different things, add them together to get the total number of moles. So, it doesn't matter which one we start with, let's start with sulfuric acid. The number of moles of sulfuric acid, CV, remember concentration has to be in moles per decimeter cubed, so that's 0.2, which we figured out earlier, times by the volume, which I just get from my diagram. Look, it's all there, it's nice and easy. That will tell me my number of moles of sulfuric acid. I've now answered question A, find the moles of sulfuric acid. In the exam, get like a 2p coin or a pen lid and stick that there, so you can follow where you are. I now know my moles of sulfuric acid there. I can't do that as obviously it'd fall today. So, I've now found my number of moles of sulfuric acid. That's the did my. I've found the moles. But we don't care about sulfuric acid, we care about aluminium carbonate. Did my elephant. So I'm going to use my balanced equation to convert my moles of sulfuric acid into my moles of aluminium carbonate. It is a 3-to-1 ratio, so I must have a third of the moles of aluminium carbonate. So moles of aluminium carbonate in the titration is my moles of sulfuric acid divided by 3, 0.00243 recurring. So my pen lid or whatever is now there. We've now got a sample. Did my elephant suck? So sample comes next. Do I have a sample? Well, yes, I do. And again, it's really easy to see because I've drawn a diagram. For a sample, we need to find a sample factor. The sample factor is the larger volume divided by the smaller volume, which in this case will come out as 10. As I'm going from the small volume to the large volume, I will need to multiply my moles by 10, by the sample factor. If I was going from a large volume to a small volume, I would need to divide by the sample factor. But I'm not. I'm going from here to there. I know that because I kept track with my little pen lid. So from there to there, so I'm going to take the number of moles in my original small beaker, multiply it by the sample factor to get my number of moles in here, which is 0.0243 recurring. I now know my number of moles of aluminium carbonate that has reacted with sulfuric acid. Let's bank that somewhere. In an exam, maybe put it in a box so you can see it that easily. Next, I need to figure out the number of moles of aluminium carbonate that has reacted with nitric acid. So it's almost like a separate question now. So again, I need a new equation. It works out as a 6-to-1 ratio. So did my, I'm going to find the moles of nitric acid that reacted, CV, which I get from the diagram, which will give me this number of moles. Did my elephant use the molar ratio to convert to the moles of carbonate, so divide by 6. So I now know the number of moles of aluminium carbonate which reacted in here. Did my elephant suck? Well, there is no sample because we added the nitric acid before we took the sample out. So there was a sample in sulfuric acid, but not with nitric acid. You don't always have to suck. So did my elephant suck? Yeah, been through that. I now know the number of moles of aluminium carbonate that reacted with nitric acid. So just try and remember these two numbers. Here's my moles of aluminium carbonate that reacted with sulfuric. Here's my number of moles of aluminium carbonate that reacted with nitric. Blue Peter style, here's what I did earlier. The total number of moles of aluminium carbonate that reacted, that there was, is the moles that reacted with sulfuric, add the moles that reacted with nitric, so bang those two numbers down from before, whap them in a calculator. This is my total number of moles of aluminium carbonate that reacted. You just add the two together. Almost like that's question 1, that's question 2. Now we're adding them together for question 3 in a way. Did my elephant suck? The next bit is my, did my elephant suck my? The second moles equation always starts with what you're trying to find out. But remember, percentage purity, what we're really trying to find out is the pure mass. So that's going to start mass of aluminium carbonate equals, which is moles times Mr. Get the Mr from the periodic table, again bang it in a calculator and you'll get this mass of aluminium carbonate. All we then need to do to get our final answer, did my elephant suck my auntie, the auntie stands for answer, is stick that in our percentage purity equation. Percentage purity equals pure mass over impure mass times 100, not yield, percentage purity. So I know my mass from here, I know my impure mass, again, because it says it in my original diagram. It should all be there if you've done it correctly. Stick that in, don't forget to times by 100 and you'll get your answer. Don't forget units, percent. Is it 3 sig figs at least? Yes, that's a minimum of 3 sig figs. I'm nice and done. Did my elephant suck my auntie? But few extra tricks in that our chemical we care about reacted with 2 different chemicals. You need to find the moles that reacted with one, find the moles that reacted with the other, and add them both together to get your total moles that reacted. Okay, I'm going to make a second video on another question like this. Do watch this one first and then the other one, and then you should be done at moles.